All right, welcome everybody. You're here for memory forensics using virtual machine introspection for cloud computing by Tobias Zillner. A couple brief notes before I begin. Step by the business office located in Bayside AB during the day, and for welcome reception from 1730 to 1900 tonight. The Black Hat Arsenal is on the Palm Foyer on level 3. Join us for the Pony Awards in Mandalay Bay, BCD at 1830. Also, thanks as always for putting your phone on vibrate.
Hello, and welcome to my talk about memory forensics using virtual machine introspection for cloud computing. Thank you for the nice introduction. It's a great honor to be here and talk to you guys. But first I want to start introducing myself. So my name is Tobias. I'm from Vienna, Austria, and I'm running my own IT security company. I work as independent security consultant and researcher. I do there most of the time consulting, audit, training, and advisory services for my customers. I also do security research. So in the last years, I've done some stuff on the Internet of Things, especially wireless communication like Zigbee security or smart homes. And also in my free time, I like to do some reverse engineering on wireless communication using software-defined radio, because that's just a real cool technology. So what is it about today, and why do we need it? So today I want to introduce a working prototype of a forensics as a service concept. So my goal was to give users the control to do their own forensic investigations in cloud environments. Because at the moment you are very reliant on what your cloud provider is offering you, what methods, what data you can get, and it's often very, very slow to do the incident response process. I want to give the users, the end customers, the end users a possibility to speed it up and be in control of their own investigations again. So what I did is I just integrated memory forensic services into a cloud environment system and using a cool technology called virtual machine introspection. So I noticed VMI a couple of years ago and then thought, okay, that's very cool and very powerful. How could you use it? And I came up with this prototype. Oh, wrong direction. Okay, first I want to start with a little introduction and background, then take a deep dive in virtual machine introspection, how it works, what it is. I will bring up some use cases and talk about more detail about the prototype, what components I use, and how they fit together. Yeah, and then I want to conclude with a summary. First, I want to talk more about my motivation. Why did I do this? So the relocation of systems and services in the cloud is clearly on the rise. Everybody knows this, but for forensics, that's a very hard step, because you lose direct access to the system. You are very reliant on third parties, what they are doing. From the organizational setup, so do they have the processes and guidelines how to enable customers and provide them the data. But there are also a lot of technical issues when it comes to forensics in the cloud. I just want, again, to enable the users to do their own forensic investigations. And also for me, it's always very important to bring up working examples, not just talk about theory, also try to make the last step and give the users, okay, a solution, you could use it this way. It works, and maybe you could enhance it or fix some bugs, but you can start here. So what is virtual machine introspection? It's defined as, virtual introspection is defined as the process by which the state of a virtual machine is observed from either the virtual machine monitor or from some virtual machine other than the one being examined. So outside the guest VM or your VM, that has a lot of advantages if you do the monitoring from outside. So in my scenario, in my prototype, you will find a kind of a hosted virtualization solution where the hypervisor is running on a host operating system, And my services are, as you see on the right, yeah, you see it, running also as applications on the host operating system. So I developed my own memory forensic services for communicating with the cloud front end and giving the users forensic possibilities. When it comes to virtual introspection, you often find a problem called the semantic gap. So it's not really a problem, it's just inconvenience, because there is a difference between the presentation of the data to the operating system and the raw data format. So when you introspect virtual machines, you have to do the same calculations as the operating system does to get the real information out there. So this requires some kind of pre-knowledge when you want to do virtual introspection. So you need to know, is it Windows, is it Linux, how is the operating system processing data, how is the data structured. Without this knowledge, you just have you have a gap in there and you don't get the semantics out of the data. So you need to have at least some knowledge about the guest operating system. How does it work? So this is an example I borrowed from the LibVMI website. LibVMI is a virtual machine introspection library I also use in my prototype. It's really cool. It works with different hypervisors, and the operating system has a lot of good features in there, and it's also constantly enhanced and bugs are fixed in there. So when a VM or application, VMI application, for example, this is an example for how to introspect or how the introspection works to view a kernel symbol. So the VMI application just requests the kernel symbol to from the VMI library, and the VMI library looks it up, the virtual address for the symbol in the system map. So afterwards, the VMI library then checks the kernel page directory and maps the right kernel or the correct page table. And then afterwards, as always, the page table is mapped to find the right data page. And then it's just passed the way back to the VMI library and to the VMI application. So all the magic is happening in the library. So the library is taking, is in control of managing the translations and computations, and you also have to configure do the configurations for the VMI library. So this is how does such kind of a configuration looks like. This is an old configuration of a system of mine. You just have to define some offsets, some addresses, what operating system type it is. So that's very basic. And LibVMI also offers some auto guessing of the introspected operating system. So that makes it very easy for the popular operating systems like Windows, Ubuntu, whatever. You will find it automatically. So what advantages brings VMI? I think the biggest one is you don't need to do any kind of stuff on the target system. You don't need to alter it, you don't need to manipulate it, you don't need to install it. You don't need to do anything on the guest operating system. It is also very hard to detect because nothing is done on the operating system, on the guest VM. So even if you have malicious software installed, they won't find any hints on there that there is a system monitoring the VM. Also, it enables you to do real life analysis of the memory content. You don't work on snapshots or the storage. You can do really behavior-based analysis and really work on the live system. A general advantage of memory forensics is the data size for analysis. So you don't have to, when you just get a hard disk image, you have terabytes of data sometimes, but memory is smaller. You can, you don't have to search the kind of huge amount of data for the smoking gun. So that makes it memory forensics a big advantage over hard disk forensics. Also, you could, for example, detect memory-only malware. So malware that never is written to hard disk, you could detect this way. And for me, it's also you get more reliable data. This means, state of the art, you have your VM running in the cloud, and you think, okay, maybe there is an issue, maybe something is wrong there. You want to do a short or a quick investigation. You don't have any methods to do it. So what you do, you maybe try to run the investigations from the compromised systems because you don't have any access. This means doing forensics on the compromised machine doesn't get you reliable data because maybe the malware is intercepting system calls and providing you false information. So doing it from an external source is the only way to get good data. But you have to be honest, there are also some countermeasures out there. You could, for example, do timing analysis, how to detect that you're introspected. Just try to detect patterns and the frequency and that the VM is scheduled for execution. But my personal opinion, that's not very reliant because you can't predict it. There's also a way of doing, for example, page fault analysis. That's better. You just check on your VM how many page faults you get, and maybe there are unusual patterns. Because sometimes the introspection just loads data pages from swap, or some data pages get swapped, and you get page faults that you shouldn't, that you don't expect. Also, more not only detection, more a prevention or protection mechanism is DKSM, direct kernel structure manipulation. As mentioned before, VMI assumes some data structures. When you then manipulate and change these kind of structures, you prevent VMI happening because VMI is reliant on the data structures. If you change them, this doesn't work anymore. So you can do just delete, add, manipulate the data structures, or you could also change the semantics. But to do this, you need a kernel level access. So you have a big problem if it comes this way. What fields of applications are out there? Just a few examples. For example, you could do crypto key extractions. That's one of my favorite applications because when you think about in combination with network forensics, you now have all the keys to look into encrypted channels and do maybe deep packet inspection and secured communications. It's tougher now to do this kind of stuff than in the past. In the past, for example, TrueCrypt keys were very easily detectable or findable in the memory. Now they are taking some obfuscation measures to make this stuff harder. You could also do intrusion detection systems. VMI offers the advantage that you can combine the advantages of host-based and network-based intrusion detection. So host-based offers good data access, but also big attack surface. Network-based IDS, you get less data, but you don't have such kind of a big attack surface. VMI combines these both. You have good data and a very small attack surface. You could also do rootkit detection, for example, from outside. Think about the example from before. Malware is intercepting system calls and trying to hide itself. With introspection from outside, it's not possible this way because you're not relying on the data the operating system is giving you. You're doing the calculations and following, for example, the process map your own. Okay, and then let's get to the prototype. The interesting stuff. So my solution approach was I didn't develop all the stuff my own. Most of the stuff I just reuse and combine it. So the existing tools, it's open source. So everybody can is able to put your hands on it and just develop it further. I tried to implement minimal overhead, so it should also be performant, and users don't have to do a lot of configuration stuff and don't need a second interface, for example. So minimal overhead and transparent for the user. So what do I mean with transparent for the user? So I'm a big graphics guy, as you will see. My use case is attacker is doing some malicious stuff on the user VM, and the cloud user is just using the used way, communicating with the cloud front end and starting off the investigations. And it's not this way, direct access to the user VM, it's indirect access. So you don't have to do the investigations from the affected user virtual machine. I have a lot of components merged together. The most important one is OpenNebula. I chose as a cloud solution. It's open source based. It's very good documented and out there for a long time, and it's also maintained. That's very good. For hypervisor, I used Xen, but you could also use KVM or others. It was just Xen was the best documented for working also with LibVMI, the Virtual Machine Introspection library I used. And as forensic tool, I used Volatility for memory forensics. But you could also extend it and just add the tools you want. It's no problem. To make this working, I developed some memory forensic services to manage the investigations on the analysis, and to put some security features in there. Because you can think of, if you have a very powerful technique like VMI, if you miss out some security stuff, you have big problems, because user segregation is important. You also share the resources in cloud environments, so you don't want to have users read the process lists of other VMs or get the memory dump of other VMs. So that's the basic architecture, very basic. You have a cloud management server, there are your usual cloud control services, you have a cloud node, host operating system, hypervisor, and VMs. And then on top of this, on every node there is a memory forensic service deployed, and also in the cloud management server there's a memory forensic service. So if you then start your investigations, you use the normal interface, and the cloud control services just call then the memory forensic service. And it's going in this way to the cloud node. It's calling the forensic tool you want, in this case Volatility. And then using the VMI library, you get the way into the guest operating system. So that's really very basic, but in reality you have to do a lot of extensions to it. That's the architecture of OpenNebula, and every red star is the point where I needed to do some extensions, or I also have had to extend the database to store the results of my analysis. And like most of open source projects I know, it's very good documented the traditional way, but when you want to do some more advanced stuff, it's hard to do it, and it took me some time to make it really working in the real world. So the memory forensic services, they're self-developed. It's based on a client-server model. They're platform independent. This means at the moment it's in Java, but I tried to port it in Python. At the moment I use PKI and certificate-based authentication for secure communication, and very important command whitelisting at the moment, because Volatility offers a lot of powerful features, and I don't want to give the user the possibility to apply all of them to the VM, because it's very hard to segregate the user space at the moment. That's one of the biggest challenges, I think, if you want to take this to the real world. Make really sure users can't see stuff from other users. At the bottom you will see that one VM is the command for OpenNebula for the command line interface, and the mem for memory forensics. And you just add your VMI ID and what command you want to execute. So that's really easy and transparent, because it's the usual way the command line interface is working. What advantages do you get? So the user gets real easy access to the data. He doesn't need to do any changes to the target VM, and it gives you the advantage that you can do memory analysis on a compromised system now in a cloud environment. So that's not possible before. Or with, I don't know the cloud provider offering this kind of services at the moment. My personal experience is always very hard to get data for forensic investigations at the moment. You don't need to stop or pause the system, so that you don't affect the traditional operations, so your services are still up. You can do it on the fly and really live. Also, for me, a handy feature is you can do the analysis on the cloud node itself. So you can, for example, let Volatility on the cloud node do the analysis and just pass the results back to you. Or that's a reduction of the network load because you don't have to transmit a lot of data. Or you just pass the raw data to the user and you then do the analysis on your system. So that's more network load, but you can do a lot of enhanced analysis. So you can run different tools. You have the real data, and reduce the local load on the cloud node. You can also advantages. OpenNebula has existing authentication authorization system built in. So I don't have to care about this kind of stuff. You have a user management. I don't have to implement it on my own. But there are also some disadvantages and security challenges. So you need configuration. In my case, I don't know what's the best way. Should the cloud provider be in charge of the configuration or the user? Maybe in the real world it should be a mixture. So the user is just ticking what operating system he's using, and the cloud provider is setting up the configuration. It's installation overhead for the cloud provider, but it's very, very small. Challenges in the field of security, obviously it's a very big additional attack surface. You have to be really careful when you add services and make your stuff more complex. Security of all the components is crucial. You have to check all the stuff you put in there. And again, user segregation and separation is very important there. Some bad news, I don't have a working demo because it's just a 25 minutes talk and it's would take too much. I applied for 50, but it was count down to 25. But I would like to encourage everybody who is interested, get to me, send me an email. We can set up a web call, Skype call, and I can show you more hands-on how it works and how it's really working and how it's the work and feel. Can also give you the code if you want. Because you need to change a lot of services in there, as you maybe have seen in the architecture overview about OpenNebula. So it's not that easy. If you want to reproduce this or enhance it, just get to me. Okay, then let's conclude. Investigations in cloud environments are more and more common. We need to find ways to make this easier for the user and the response time faster. Sometimes it takes days, weeks, or even months to get the data you want from your cloud provider. So there are legal aspects, no policies, and also technical limitations out there. VMI is a very interesting approach to solve a lot of these problems when it comes to the technical ones. Yeah, it's fully open source based, my solution, so I will put it online if someone wants, and we can discuss it further. And there is a lot of room for enhancements and this different fields of application. So be creative. VMI is really powerful and you can do a lot of stuff. Not only memory, you can do also hard disk, you can do whatever you want, basically. It's really powerful. So what do I want to give you on the way? So think about hypervisor forensics and VMI as a very powerful and interesting technology. And think about your possible applications. Maybe you come up VMI as a solution for your problems. The concept as forensics as a service, I think, is very cool, and we should give more power or capabilities to the user again, and not fully rely on the cloud provider offering services to you. Also, very general, memory analysis is a huge benefit for forensic investigations, because you can find a lot more stuff than on a hard disk image. You can also track how the attacker is behaving when you get your hands on the memory, on the live memory. Okay, I want to thank you for attention, and now it's some time for Q&A. So it's just 25 minutes. We have some time for lunch, so feel free to ask.
What's your email?
That's then the next slide. Slides will be published online. So, other questions?
I have a.
Thank you. Okay.
Sorry, I have a question. So I see in your when you are saying about there's no inference or minimize the inference. Actually, I'm wondering, like, have you measured anything about the performance impact on the host system or the virtual machine, the targeted virtual machine, and the virtual machine co-located with that virtual machine?
There was a analysis done on this. I can give you the link to it, but they did some extended tests about the performance of this kind of solution, and they came up that's very minimal overhead. But I can give you the link to it. They have written a thesis on this and made some real deep test cases.
Okay, thank you.
May I? We are working on the same solution, and I will contact you later. But I have to ask about, do you have any automatic patching for anti-VM technique?
Not at the moment, but yeah, this could be also a use case for VMI to patch the in-memory stuff. I know solutions are out there that you install on the host, and they do this kind of stuff. You can also do this in theory using VMI, just to roll it out on every VM you have. I have not done any kind of research in this field, but I think this could be a valid use case for VMI.
Thank you.
Thank you.
I hope we can join forces.
Yeah. I will be around in the next days. And,
So, question here. Yeah. So, since cryptographic key extraction is possible, is this virtual machine inspection a attack vector? Right? Can somebody use this on my virtual machine running in a cloud provider as an attack?
If you you need to have control over the hypervisor to do this. So if some attacker breaks your hypervisor, you have a real big problem.
Yeah. We probably have bigger problems than this.
Yeah, but that's also.
So when I saw that, it says, "Oh, that reverses it, right?" Yeah. And changes this from a defensive technique to an offensive technique.
Yeah, that's what I mean with challenges. If you want to implement it in the real world, you have to think a lot about securing this attack surface, because when you make one mistake, it's very powerful, and you have full control over all machines on this node. Or
right. Okay, so I wasn't making a mistake there. Right.
Yeah.
All right. Thank you.
Thank you.
So typically in a cloud environment, we don't have access to the hypervisor or the host OS, right? Normal user only has access to VMs.
Yeah.
So have you talked with cloud providers in order to see if they're willing to do this type of change in their infrastructure to provide that?
This was just a research project. Maybe we will see if somebody is interested to set this up. Yeah, but that's correct. You need the cloud provider set it up, the solution, distribute the services, the tools on the cloud nodes. Normal user can't do this.
Okay, thanks.
Thanks.
Hi, my name is Tewan. So this is interesting topic. So have you ever thought of using this for embedded system?
For embedded systems, no. To be honest, yeah.
Yeah, but I think it can be applicable to embedded system, and then thinking of using it for IDS, IPS might be possible.
Okay, I'm not. So on the embedded systems you talk about, there are also like hypervisors installed, yeah?
Yes.
Okay. Yeah, then you could do this on, you don't need a cloud for doing the VMI stuff. You can also do it local on just one machine. But I think similar concepts are out there in the real world for just one application, but not for the on the big scale.
Thank you.
Thank you.
Just another question.
Yeah.
So there's a paper called Cloud VMI.
Yeah.
Have you looked at that before? It is published in 2014.
Yeah. So the main part of my research was done as part of my master's thesis ago and on the University of Passau in Germany. And there are some follow-up stuff was done, like the Cloud VMI, and also the performance stuff was done on my former university. Yeah.
Oh, Cloud VMI, I mean another paper from the University of Utah.
Okay.
So it is doing something similar to this, and it is also doing Cloud VMI and providing something like VMI as a service.
I know the paper, but it's very similar. I did this I started the first prototype in 2013, and I did some enhancement in the past. But there are some. When I started researching in this field, there were just theoretical parts out there. So you have VMI, you have memory forensics, and then I tried to start it to put it all together. And I think the Cloud VMI, I don't know what's the outcome of it. So did they also provide a prototype? Because I think they're also using LibVMI, for example. Everybody's using it because
we can have more discussion offline because I'm in that group. So, Okay, thank you.
Okay, then let's talk later.